Hello guys, thank you guys for tuning in to another video of 5-Star Physics, and today we're going to be talking about vertical motion and free fall. So, say you have an object, this object here, okay? And this object is just in space. Um, not in space, on the Earth, but nothing's interacting with it, nothing's touching it, it's just falling from a building, right? What would you say is acting on it? Well, there's nothing in contact, so you know, there's nothing. It's just there. But that's actually not how it works because there is something acting on it, and you know it, and it's called gravity. So gravity is pulling down on this object, pulling it towards the earth. And this motion of gravity is what we call free fall. And free fall is basically when the only reason an object changes its motion is due to gravity. The only reason it changes its motion is because of gravity. So the only reason this ball is falling to the ground is because of gravity. There's nothing else causing it to do so. Now, there's two different ways that gravity could occur. Something called dropping. Okay? If I drop this ball off a building, the horizontal velocity, Vx, is zero because it's not moving right, it's not moving left because I dropped it. I didn't apply a force, there's no velocity going right or left, it's just going straight down. There's also something called throwing, like I throw a baseball. Well, in this case, Vx does not equal zero because I could have thrown it to the right, I could have thrown it to the left. You don't know. So you can't assume that the horizontal velocity equals zero. I have another question. When the ball is going down from the top of a building, what is its acceleration? Well, let me tell you, don't worry, you don't have to calculate, you don't have to know anything. It is simply a constant, which means the value of value of an object in free fall is going to have the same acceleration everywhere on Earth. This acceleration is represented by little g, and little g stands for 9.8 meters per second squared in the negative direction. So this ball has an acceleration of negative 9.8 meters per second squared. However, it's important to know that when you're calculating, usually you don't have to mind negative because usually you're just calculating for magnitude. Okay, so this ball is going down 9.8 meters per second squared towards the ground. But it's also important to know that it can also be represented as 10. And on the AP exam, use 10. Do not use 9.8. 10 is also very, very simple, much more simple to use. You can calculate it in your head. There's going to be problems on the AP exam where you may have to calculate something in your head. And instead of using more time to use your calculator and have to do all this, it's much easier just to know that it equals 10 on the AP exam. So that's really important. It equals 10. Okay, but a lot of people are always like, okay, but what about air, right? What about something pushing up on this ball? Like gravity's not the only thing acting on, there's also air. Don't worry about air. Air resistance is not really talked about in Physics 1. It's not important. It's always negligible, okay? And you don't have to worry about it. Now, say that you were solving for the acceleration of this ball. Well, in that case, A equals G, right? So then also in that case, if you were solving like a kinematic equation saying VF equals VI plus AT, that would also mean the same thing as VF equals VI plus GT. And this is really important because on the AP exam, you're going to have to know the difference. If something's in free fall, you're going to have to identify that and be able to plug it in to that equation to be able to solve because it might give you the value of G on a random planet. Okay, and then it's saying solve. Well, how would you solve? I only know kinematic equations. This is the way to solve, by knowing that A equals G. So let me give you a hypothetical here. Say you had a ball and you threw it in a curve to your friend. You're playing catch. The ball goes in an arc-like shape, like I guess shown here, right? And the question is asking you, what is its velocity? Well, delta x we know, okay? And t we know. Okay, so let's solve. Well, we know that delta x over t equals v. So that means the slope of this line here is going to be our velocity. Perfect. But then how do we find the slope of a curve? Well, the only way to do that is to use calculus, and you have not learned that yet. So we have to treat it as 2D motion. Before we talked about how we assume it's only one-dimensional. That's true because we can't do calculus. But we can use that one-dimensional aspect to combine vertical and horizontal. And let me explain. So you can take this V here and you can break it up into components, Vx and Vy. Because, think of it like this is a little vector math. If you have Vx and Vy, what would that hypotenuse be? What would be V? So, to find V, we have to find its components and then use a triangle to solve for V, right? Use Pythagorean theorem. So, we would look at its velocity horizontally and its velocity vertically. And then from there, we could find what V equals. And this is really important because you're going to be asked to do this in many different problems because calculus is not expected of you, but 2D motion is. So what would we call that movement of a ball in a curve-like shape? Well, we have a specific name, and it's called projectile motion. All projectile motion is free fall and horizontal motion. So basically, it's combining gravity and horizontal velocity. So what it basically is saying is that the only reason an object changes its motion is due to gravity. Okay? In free fall, it's the only reason an object starts moving is because of gravity. Right? The only reason that it's going towards the ground, the ball towards the ground, is because of gravity. For projectile motion, the only reason that a ball would land here instead of out here would be because of gravity, because of free fall. And that's basically all projectile motion is talking about. It's describing the motion of a projectile in motion. So here are just some quick takeaways that I want you to take away from this video. The first being of free fall. So free fall is just basically when the only reason an object starts moving is because of gravity. So the only reason that it's going towards the ground is because of gravity. The only reason that it changes its motion is because of gravity, but in the vertical direction. And then projectile motion is just a little bit different. Projectile motion is basically saying the only reason that a projectile is changing its horizontal motion is because of free fall, because of gravity. And also, for free fall, don't forget the difference between dropping and throwing, because you're going to have to assume specific stuff. Dropping means that V equals 0, Vx. Throwing means that Vx does not equal 0. It could be negative, it could be positive. And the last one that I want you to know is the constant of G. Know it as 9.8 meters per second squared to calculate in your classroom. But for the AP exam, you can also use 9.8. They won't take off. But to get that exact value, to get the exact value they're looking for, use 10. Thank you guys for tuning in about free fall. In our next video, we're going to be wrapping up kinematics and talking a little bit about relative motion and linearization, and then we're going to be moving on to forces or dynamics. Thank you guys for watching, and have a good day.